Hi, everybody, and welcome to our session on Tales of a Tech Transformation in a Constrained Environment. My name is Kieran Kavanagh. I'm the Principal Architect for the Wayfair account here at Google Cloud. I'm joined on stage by John Keane. John, would you like to introduce yourself?
Yeah, hi, my name is John Keane. I'm a Director of Engineering at Wayfair. I support teams that handle the product catalog, pricing systems, back-end API integrations with our supplier community, as well as analytic environment that powers the environment that powers the analytic use cases, as well as machine learning use cases for our data scientist community.
Awesome. And today we're going to talk about Wayfair's digital transformation program on Google Cloud, as well as some of the challenges that these kinds of programs present to customers. So pretty much all companies who go through large-scale transformation programs face these kinds of challenges. And specifically, we're going to talk about how Wayfair is using generative AI to address these challenges and to accelerate their transformation program. And we will run it a bit longer than the 15-minute allocation, but we will be hanging out at the side here for questions afterwards if anybody wants to dive in deeper. Let's begin with the background, some context, perhaps on, John, if you could talk about some of the challenges that Wayfair has been facing and how they're being addressed.
Yeah, so I think the easiest way to think about it is if you kind of take a step back and kind of go back Wayback Machine. Wayfair's been around for a long time, since the 2000s, and back in those point in time, it was very common for teams to read and write directly from databases. That was a very common pattern. Setting up things like caching layers and hosting was a much more difficult process then. I mean, today you just go into like Cloud Explorer, push a button, and boom, you've got an environment. But that wasn't the case then. And so where we kind of emerged about a year ago was we were in this system where we had all of these client teams across our company making direct reads and writes out of the database. And these are large multi-terabyte databases, hundreds of terabytes of data. They were 100, 200 teams across Wayfair. We have a 3,000 person-ish engineering organization. And so all of this was happening, and we knew we needed to get out of these large-scale SQL Server instances and get into a cloud, more scalable cloud infrastructure using Google Cloud. But to do that, we had to kick everybody out of these databases because everybody was making these direct connections. Teams couldn't figure out how to decouple because there was all this interaction. It just wasn't I think many of us are in that same situation. It was not a practical solution. So as we kind of entered this process, we knew we had, where's the button here? We knew where we were. So if you look on the left-hand side, this is kind of our legacy stack, which again, nothing revolutionary. It's a controller logic, but all these things were making direct reads and writes from the database. These, all of these interactions, and we're talking about trillions and trillions of reads and writes every single month, and we're talking about ranging from simple selects all the way through to complicated correlated subqueries, or even store procedures, which even gets gnarlier. And many of these things were undocumented. As people have been doing this over tens of years. Things have grown organically, and we didn't have people are no longer with the company. So we had to understand this space. And we knew where we wanted to go to, and where we wanted to go to was Apollo Federated Graph. And the reason for this choice was because we wanted to create this abstraction between the client and the database. Today, where we sat, at the beginning where we sat, was we had this very, very tightly coupled ecosystem. So if you wanted to make a change in a given system, let's say the business came to us and said, hey, I want to test this feature. Well, that feature would have to be spread across 10 or 15 different systems just to make a simple test. A complex one would be maybe 20 or 30 systems and require much larger investment. And this was because everything was tightly coupled. And so when we thought about where we wanted to go to a federated graph ecosystem because that abstracted the client completely from both the service layer and the data layer underneath it. And so that's kind of the decision that we made. So we knew kind of where we were and where we wanted to get to, but we had faced some pretty significant challenges. The first challenge was discovery. And honestly, again, I think everybody here faces a similar problem, which is you've got these systems that have grown organically. People are no longer here. I don't know about you, but documentation is never maintained at any place that I've ever been. So you have documentation that may be a little bit older, and we now had to face a thing of I need to take this thing and move it to there. And by the way, it's not A to B, it's A to Z, because the last thing that we wanted to do was to take a 150 column table in SQL and then map it into GraphQL as 150 attributes. what we wanted to do was we wanted to go from those 150 columns to maybe 10 or 15 different data domains in our federated graph domain ontology, so that it actually transformed the business and it made sense and it provided that abstraction from the source data. And then once you get that done, like you need to do that, but then you have to create all these backing services, because now you're going from this one table with a bunch of selects to 15 different services. You have to do this across hundreds of engineering teams and do it consistently and do it with performant queries. So we were kind of facing all these things, and then on top of it, replacing all the live traffic. Like that was the kind of one of the big steps in all of this, because in our product database, there's 250,000 code references in our GitHub repo. If you actually take it across all of our databases, there's probably upwards of 1 million different code references that we have to actually get out of all of these different queries directly to the database. So, and then finally, all of this is in service of getting it out of SQL, like we've talked about, right? Like getting it out of SQL and getting it into modern cloud storage. So that was kind of what we faced at the time, and then as we kind of started down this process, we started out in a very straightforward way. I think everybody will kind of resonate with. We get a couple teams together, you see how it goes, because these 6,000 code references that we started with, there's maybe not 6,000 different implementations of it. Maybe they follow 10 or 15 different patterns. We thought maybe we could kind of do this, start down the traditional approach. But early on, it was, we were kind of doing basic math. And by the way, one data point here is, at that time, we were averaging about 1 query replacement per contractor per day. Today, with Gen AI, even in the early tools, we're about 6 query replacements per contractor per day, and that's on the first generation of these things that's going live. So that's a substantial improvement, and again, at scale, that really magnifies the savings for us. But I'll talk more about that in the future. But like at the end of, kind of as we go through it, we basically have these, we basically were faced this problem, and that's where, Karen, you and I started talking about this and realizing that even Wayfair and Google were largely focused on kind of the developer experience. I want to replace this code while I'm writing the code, but for us, we don't want to bail out more water. We don't want to be putting water back into the boat with the bad patterns as we're trying to bail it out. So that's how we talked the following week.
Absolutely, John. And, just kind of double-clicking on that a bit, it's really important, this partnership that we're working on together on this. Of course, Wayfair and Google work together on many different things. Wayfair has a close relationship with Google, including cloud, ads, and other alphabet companies. And even within cloud, we work on lots of different things together. So as you can see on the screen here, there's a number of different areas in which we work together. The cloud digital transformation is one of the main ones where we're spending a lot of our time right now. And in the context of that, even within that, there's a lot of different things that are in play. What we'll focus on mainly today are the areas in the blue boxes here. So AI/ML, generative AI, and using generative AI to accelerate the database transformation. And so, yeah, it's very much a co-investment from both sides. Right. So with that in mind, though, considering that we'll be talking about generative AI, I'd just like to get maybe a show of hands from the crowd. Has anybody here heard of something called Gemini? Okay, awesome. So we will talk about Gemini today. This is a Google Cloud Next conference after all. Just a quick level set on what it is. It is Google's most capable family of generative AI models, built to be multimodal from the ground up, capable of sophisticated reasoning and all kinds of different things. But what we're going to focus on today mainly is the advanced coding aspects. And so we'll talk about how they're being used in this program. With that in mind then, John, perhaps if we could start talking about some of the approach that Wayfair is using to actually use generative AI for acceleration.
So we knew we wanted to use Gen AI. We knew we needed to radically accelerate what we were doing. We needed to take a 4-year program and bring it down to about a year. And we needed to be able to run multiple databases in parallel. Like, we couldn't do these serially. Otherwise, like I said, our first attempt, it would have slotted it somewhere around a 4-year program, which I don't know. I don't know anyone here, but their business owners would not let you go spend 4 years doing something. That was the smallest database of GST, my team's legacy footprint. I mean, the other stuff would have taken 5 to 10 years just on the simple math. So we knew we needed to do something radically faster, and that's where this system, our model pipeline, has really helped us. We know where we were, and we knew where we wanted to get to, but how did we build a model? How do we build a model pipeline that allows us to get there? The first thing, and I'm going to go through this a little bit fast just because I want to leave time to show some code examples that we actually are running in production. But the first step is to really analyze our current state. And the reason why this is important is because, as you'll see in the future examples, what we don't want to do is go from A to B. We want to go from A to Z. We want to take it from a 150 column table to 10 or 15 different data domains and type definitions in GraphQL. We don't want to go to 150 attributes. We don't want to just to make a map and just kind of persist and kick the can down the road. So the first step is to analyze it and take our corpus of knowledge, things like Confluence, things like Jira, things like GitHub repo, things like our Google Doc design docs, and really have the models understand the environment that they're in. And once you understand that, now you can start to decompose and build the GraphQL schema and the domain ontology. And that's really, really critical. So again, you go from that 150 down to 10 or 15 different things, and then stand up the APIs. Again, we need to migrate all these clients that I talked about, millions of different code references that we need to actually move to a new platform. And we can't do this in a way that just asks teams to do it. We need to actually be able to push out these automated PRs to every team and say, here's the code that we need you to replace. And finally, I mentioned, like, we didn't have, like, a lot of the stuff we have are really very strongly manual steps in a lot of places. We have tons and tons of automated tests, but like I think everyone here is, you never have enough, and you never have enough code coverage. So this is area where we wanted to not only improve the code coverage, but improve the code reliability and readability as well. And we used a number of models in this. We used Palm. We used, obviously, Gemini Pro 1.5. That's been a huge improvement in the code capabilities. And then Bison, Unicorn, and others. But notably, we also use vector search to actually help incorporate and pull some of these corpus of knowledge so that we can actually really, really start to make progress in this space.
Awesome, John. Yeah, and as you mentioned, I think Gemini Pro 1.5 has been like a really game changer in all of this process, especially with the larger context window, et cetera. That's been very helpful in these activities. And thank you for laying out the overall strategy. I think the audience would probably love to hear a lot more about how each of the individual steps are being addressed. So maybe if we could start with that, with the SQL to GraphQL conversion use case.
Yeah, I think we have about 7 minutes, and we'll spend more time taking questions. So I'm going to go through this kind of quick, but I'm happy to spend as much time afterwards as needed with people who have questions. Just an example. Here's a typical prompt that we give Gemini Pro. You're a GraphQL expert. The thing I want to call out in this prompt is that we actually ask it to spell out the GraphQL field names. We're not giving them that mapping. We're not giving the models that mapping. It understands it through the analysis step. And then also produce code that's compilable. It's really, really important to us that once we produce the code that we're able to hand it off to the dependent teams and have them take it and put it in production with under a day's worth of work. Because again, if you think about this, if we just even scale this out and give them something that takes a week or whatever to do, it just is a non-starter. It just doesn't get us anywhere. So again, you'll see this prompt. This is the input. This is a simple select that I'm sure everybody has in their ecosystem. It's a simple join. But you'll notice one thing to call out is like OPPSID, OP canceled, ref prod ID. You have these things that SQL engineers have written for decades, and it's makes a lot of sense to them. But 5 or 6 or 7 years go down the road, a new person comes in, and they're like, "What the heck is this?" So what we really want is this is the output that the model produces, and this is just going from SQL to a federated graph query. But the one thing I want to call out is you notice that it took all the knowledge about what the ecosystem was, and it transformed all these references. So OP PSID becomes order product status ID, and order product quantity, and all of this is far, far, far more readable than anything that you could ask a team of 10 or 15 different engineers to produce on a consistent basis. Not because they're doing a bad thing or whatever, it's just every person has their own interpretation about what's readable. This provides consistency, transparency, as well as improved testability. And then it also produces an explanation as a result that tells you, here's some documentation we could pass along to humans in the loop about what the actual model did.
Awesome. And that was a really good overview of the SQL GraphQL conversion. And we know if we map that back to the original strategy, that's just one piece in the puzzle, right? So at this point, now you've stood up your new service layer, you have your new schema, your new resolvers and backend services for interacting with the databases. But you mentioned upwards of 1 million code references throughout the code base, right? So all of these now need to be updated to use your GraphQL interfaces, which is not an easy task. So maybe if we could jump into that a bit more and talk through that.
Right. So here's an example of a prompt. Oops. Can you go back one slide, actually? Well, here's a, oh yeah, thank you very much. Here's an example of a prompt we use for PHP. This is, again, going to show an example of replacing a PHP function with a function that does the GraphQL query. Exact same code that you just saw before, the same select, and this is just going to be on the client-side replacement. So again, we're asking it to do a particular way to make the GraphQL client call, and then here's the PHP function. We have an example here. It's the exact same query, and then the model output actually produces this, which is, again, very readable, very well formatted, has tests wrapping it. I'm not showing the tests here, but this is an example of where we can pass it on to a team and say, here, this is the work that we did, and it also includes an explanation as well. This is accelerated, by the way, on the GraphQL query that I showed you earlier. On average, it was taking us 12 hours to do one of those at the beginning of this process. We're down to 4 to 5 hours now, or 4 hours actually. So it's a huge savings in just the SQL to GraphQL query. And I'm going to talk a little bit, and I'll talk a little bit about the stored procedure. It's even more dramatic.
Right, John. So I guess when we get to stored procedures, the complexity level raises quite a lot, right? So it's no longer individual CRUD operations. A stored procedure, as the name implies, is a procedure. It is a sequence of activities. You might have 100 things that needs to happen before that's considered to be complete. And so also when you bring that logic out of the database layer up into the application layer, now you need to implement your own orchestration, right? And your own like saga patterns and compensating actions. Let's dive into that a bit more.
Yeah, so I'm going to, and again, we're running low on time. I'm not sure how much time we have remaining, but I'm going to go through these pretty quick. Again, I'm able to talk more in detail. When you think about stored procedures and these large number of functional blocks present in any unit of code, what we need the system to do is to do two broad steps. One is plan and one is execute. So when we actually talk about planning the code, that means decomposing the various steps that a stored procedure does. I'll show you an example here in a second. Separate them into functional code blocks. We need it to think about things like, is it even feasible? Because in some cases there may be actually using queries that are very non-performant, doing table scans or whatever. And in those particular cases, we need to recommend that maybe there's a different pattern that we need to employ, like event state transfer or something where we actually do the code in a different way or move the data around in a different way because it's not feasible to lock up the client with a 30-minute call or something that a table scan might generate. So again, we wanted to plan, we wanted to produce a feasibility assessment, and then we needed to decompose it into functional blocks. Once all that's done, then we actually have the model pipeline actually do the work. And I'm going to just kind of step quickly into this. Here's an example of a stored procedure. We have, it does three things. I won't spend a ton of time on it, but it does basically three things. It checks to see if an overpack load exists, and then if it does two updates. One, an update for the actual weight, and then an update on the carton count. So again, this is just something an engineer, again, not complicated, but something an engineer can do, but doing this at scale with hundreds and hundreds and hundreds of stored procedures is a much different problem, and to do it fast. So we have it produce, and this is the output from the feasibility assessment. It says there's a single domain involved, simple reads and writes, there's a low SQL complexity, data volume. It also incorporates knowledge about how it operates in SolarWinds. So it says, hey, this runs pretty fast in production. So it's all of it means it's a good candidate for transformation. So then the model pipeline then proceeds to the next step. Here's an example of the decomposition. Again, nothing really that complicated. A JSON block where it separates all the different elements. You'll see that it says, hey, I need to do 3 functions in Java, 1 check, and then 2 updates. But the interesting thing to note is that it also understands that we need to put in compensating transactions. There's a lot of things SQL gives us for free, like rollback of transactions, commits of transactions, atomicity. And so the models actually understand that and also build in functions to roll back events in case something fails over the cycle of running the function. And so here you see in that slide you actually saw the compensating functions, and here's the actual code that's produced in the Java libraries to actually replace in production. Now, in this version of it, you see SQL injected in this. This is an early version of the code. In the current version of the code, it'd actually be a federated graph query or a federated graph mutation, depending on whether it's a read or a write operation. But this just kind of gives you an example of the kind of code that's produced. Again, here's the compensating functions. Nothing really substantial here. But when you actually look at this function, this is what we call an orchestration function. And what this function actually does is it mirrors what the store procedure does in Java. So again, this is code that is actually produced. All the teams can use it. It's actually maintainable. It's different than a traditional ORM or something that's really more of a black box in terms of what's being done. And it's actually really something that the team can maintain, and it's really well documented. It has consistency. So you see it do the actual function call to do the read, and then do the 2 updates and roll back anything that's necessary. Again, the time to do the actual tech transformation dropped, in our particular case, from 4 to 5 days per store procedure down to 6 to 8 hours. Which is a substantial, and that's in the early versions of this. So it's yielding substantial results, and we're just going not Gen AI. We're going general availability within the company with these toolings this month. So you actually see all this stuff come very, very early on into our experience. And again, it's allowed us to compress a 4-year cycle down to a 1-year cycle and actually run multiple database transformations at the same time. It also improves customer satisfaction because our clients are no longer waiting for these long kind of tech transformation initiatives. They actually allow us to get back to the business of producing customer features faster. It reduces risk on those low-risk investments as well as complex projects, and improves consistency in the quality of the code. And it also produces documentation for legacy stuff that's kind of been long forgotten. And none of this would be possible without our partnership and the earlier conversations that we had about the need to co-invest, because candidly no one was doing this in the industry when we started talking about this. And even Google and Wayfair were largely focused on how do I change it at the time that the developers are writing the code. And as we talked, we needed to fix the platform before we actually started telling developers how to change their code, because we didn't want to be making more debt as we went.
Exactly, and as you mentioned, like the partnership on this, we've seen some really great results so far on the work that we've been doing together. It requires a lot of work from both sides. There's teams of experts both at Wayfair and Google working really hard to make all this happen. The models are accelerating their work, but also, one of the reasons why, of course, we're leaning in so hard from the Google side, from the Google Cloud side, is this is a pattern that all customers can use, right? So many customers are going through these kinds of programs. Right. Generative AI can be used to accelerate these programs just as it is at Wayfair. And, thanks to all of the teams that are working on both sides. Also, thanks to all of you for joining us here today to discuss this.